In this video, we are going to discuss the October-November 2022 paper 5.2 probability and statistics 1. Okay, so let's have a look for question number 1. On any day, Kino traveled to school by bus, by car, or on foot. There are three methods here, and then the probability is shown like this. Then the probability that he's late now when he traveled by bus is X. Then late by car is 2x, and also late when it's on foot is 0.25. Then the probability that on randomly chosen day he is late, probability which is 0.235. Okay, they want us to find the value for x for part number A. Okay, so for this one, if I want to visualize my overall incidents, right, in a clearer way, I would suggest you to draw tree diagram. Okay, because we can see very clearly that at the very first part of the question, we actually have three different ways of travel to school. So we are having bus, and then we are having car, then also by foot. And the probability is shown, right? So you can just put in the probability into the tree diagram. And after that, after the method travel to school, basically you can continue to draw some branches to show whether is he late or not. All right, so I'm having late here, not late. So we have all the late and not late for all the three different methods of travel to school. So for travel by bus, if he's late, if travel by bus, then he become late to school is X, the probability. So I will write the X here. And for the not late, probability should be the complement of the X. So it should be 1 minus X for not to be late. For the car, travel by car, the probability that he will be late is 2x. So for not late is 1 minus 2x. And for the foot, late is 0.25. Then not late is 0.75, which is 1 minus 0.25. Okay. And after that, since they give us the information where the probability that on any chosen day, the probability that he is late, it is 0.235. Okay, so now according to this tree diagram, I will want to calculate all the possible cases where he's late. So the first case is by bus and he's late. So to get this probability, the value should be 0.2 multiplied with x. Oh, so this is the first pathway that he's going to be late. Another case is when he traveled by car and he's also late. So this is the second pathway. So second case, we have to plus 0.1 multiplied with 2x. And also the third case will be this one, travel by foot and he's late. So we are having 0.7 multiplied with 0.25, and all the total cases, all the total probability here that he's late will be equals to 0.235. Okay, and if I try to simplify my equation here, I will get 0.4x equals to 0.06, and continue further, I will get the x which is equal to 0.15. So this is how we actually get the value for x. If you don't want to draw the tree diagram, also no problem. Then just make sure that you know how to combine all the probability together to get the total probability for the late case. Right? So this is what you have for part A. And now let's continue to part number B. For part number B, they want us to find the probability that on a randomly chosen day, he traveled to school by car, given that he is not late. So highlight the word given that. So this word, this keyword tells us about the conditional probability. If I'm having the conditional probability, the symbol that I should write out should be B given that A. So if we have a look for the question here, B given that A means that when I try to write it out in the context, in this context, in our questions, given that he is not late. So given that he's not late means A, so not late. And then the event B will be by car. So the car is our event B in the formula, and then not late is the event A in our formula here. Okay, so as a general formula for conditional probability, So for conditional probability, it will be A intersect B divided by probability of A. So that means we already know that A happened. Okay, then we want to know the probability that B will happen. Okay, so according to the general formula here, I want to convert it into the context of the question. Alright, so A intersect B will be not late, intersect with car, divided by the probability of not late. A is not late, right? So how to get the probability for not late and intersect by car? You can have a look for the tree diagram that we have just now. We are interested for not late and travel by car. Therefore, if I have a look in detail for this question, our probability should be by car and then not late, where you can see that it is 0.1 multiplied with 1 minus 2x. Okay, so 0.1 multiplied with 1 minus 2x. So I will bring it into my calculation here. I'm having 0.1 multiplied with 1 minus 2, and then x is the value that we get just now, which is 0.15, right? So I'll put in the value 0.15 here, divided by the probability of not late. So again, if I go back to the first part, the probability of late is 0.235. Therefore, the probability of not late will be the complement case for the late case. So it will be 1 minus 0.235. Okay, so by simplifying this fraction, we will get the answer either in the fraction form, which is 14 over 153, or you can change it become 3 significant figure where it will become 0.0915. Okay, so for this part, conditional probability, please be aware that given that is a keyword for conditional probability, and you need to try to understand or remember the formula for a conditional probability. Okay, so question number 2. We have the length of rods produced by a company are normally distributed, so highlight the keyword normally distributed. We are given the mean and also the standard deviation. In a random sample of 400 of these rods, how many would you expect to have length less than 54.8? So before we can find out the number of rods that is less than 54.8, right? We need to calculate the probability first. Okay, so first of all, I know that x, which is the length of the rods, is normally distributed with the mean 55.6 and also the standard deviation is 1.2. So I will make it become variance, which is 1.2 squared. And first we need to calculate the probability for the x, which is less than 54.8, so smaller than 54.8. Since we know it is a normally distributed, right, for this random variable x, we have to standardize it become z. So to standardize it, we have to take the value minus the mean divided by the standard deviation. So the mean given here is actually 55.6 divided by the standard deviation, which is 1.2. Get the value of z to 3 decimal places, and we should have negative 0.667. Okay, then this particular area, z smaller than negative 0.667, is actually equals to z greater than 0.667. And to get this particular area, I need to take 1 minus z smaller than 0.667. Right, because for the normal distribution table, they give us a value smaller than the positive value z. Okay, so we go to the table, 0.667. Okay, so 0.6, then 6 is this one, and 7, which means I have to take 7454 plus 23 at the last 2 digits. So 7454 plus 23. What do we get here? We'll get 7477. So I will take 1 minus 0.7477. And from here, 4 decimal place answer should be 0.2523. And I will want to correct it to 3 significant figure where we have 0.252. So this is a probability. And since they're asking for the number of rods, not the probability, therefore, to calculate the number of rods, we need to take the total rods which is 400, multiply with the original probability 2523, and you get the value 100.92. Alright, so you can round off become 101. So that means there are approximately 101 roads that is having the length which is less than 54.8. Alright, so this is how we answer part A, and let's proceed to part number B. For part number B, they want us to find the probability that the randomly chosen road produced by this company has a length that is within half a standard deviation of the mean. So what is the meaning for this question? Okay, so generally it is something like this. Let's say we are having the mean, and then within half a standard deviation of the mean means that away from the mean, the distance is half standard deviation. So if I write out half standard deviation, it will look something like this. So that means the distance from the mean to this particular value here should be half standard deviation. So when we write out, it should be mu minus half standard deviation. But it is not only happen for the left hand side, they say within, it can be above or below. So we are having another value where the value, the limit is actually above the mean half standard deviation. So this particular value will be mu plus half standard deviation, and they want us to find out the probability for this value, these two values. Okay, therefore again we are doing the same thing. We try to write it out in a symbol form. We want to find out probability between mu minus half standard deviation for the value of x, and also more that are smaller than half, mu plus half standard deviation. Again, we are still in the normal distribution question, right? X is still normally distributed, therefore I have to standardize it become z. To standardize it become z, what I need to do is I need to take the original value of x minus the mean. So the red color one is the original value for x. I need to minus the mean, where this is the process of standardization, divided by standard deviation. So I put standard deviation. Same thing happened for the upper limit. So I'm having u plus half sigma minus the mean divided by standard deviation. Alright, so if I try to simplify this value, basically I'm having mu minus mu become 0 So negative half sigma divided by sigma, I'm having negative half, then z, and positive half. Okay, so to calculate the probability from this part, there are many ways that you can solve it. So for me personally, I'm using x smaller than half, z smaller than half minus z smaller than negative half. So I will look for the probability for z smaller than half, 0.5. So for the 0.5 here, you can see the probability is 0.6915. I'll put it into my steps. So z smaller than half will be 0.6915 minus, for this part, z smaller than negative half, it is equals to z greater than half. So I have to take 1 minus 0.6915 to get the correct area or the correct probability. Okay, so from here, if you try to simplify the answer, we should get 0.383. Right, so this is how we get the probability for this question number 2. Question number 3, we have 3 fair 6-sided dice, and then each with the faces marked 1, 2, 3, 4, 5, 6 are thrown at the same time repeatedly. The score on each throw is the sum of the number for the uppermost faces. So they are the sum, right? Find the probability that a score of 17 or more is first obtained on the 6th throw. Okay, so first of all, the keyword for this particular question is first obtained. Okay, when we're having the keyword first obtained, or maybe they are saying that some event is happened maybe at the how many throw, first time appear at how many throw, right? So all this kind of question, all this kind of keyword basically belongs to geometric distribution. Alright, okay, so before we calculate the probability for this geometric distribution, we are interested to know what is the probability to get a score of 17 or more first. After that, only we consider, okay, it is first obtained on the sixth row. So first, I want to find out what's the probability that my score is more than or equals to 17. When I'm having 3 dice, and the score is actually the sum of the number that I get, right? Okay, so to get the score more than 17, maybe we consider the largest value first, which is the 18. So to get the 18, basically I have only one result where all the 3 dices I get the 6. So that 6 plus 6 plus 6, I get the 18. So the first case is I'm having the probability for 6, 6, and 6. Okay, so there's only one case or no other cases. We won't get the sum which is more than 18, right? Okay, so we reduce one number. Okay, what is the probability or possibility that possible case where we'll get our score is equals to 17? So from here, I think we can see very clearly both 2, 6 and 1, 5. If I get 2, 6 and 1, 5 for my 3 dices, then I will have 6 plus 6 plus 5, which is 17. But please take note for 665, it is equal to 17. It can be also for the case that I have 656, which also will give the score of 17. And also 566 will also give us the score of 17. So to summarize it, I'm having 665, and I will need to times it with 3 because I'm having 3 possible cases with 665. I have 665, 656, and also 566. Alright. So for this question, they're asking for score, which is more than equals to 17 or more. So I have only 17 and 18. These are all my possible cases already. So to calculate the probability for this part, to get the dice with a score 6, to get the die with the number 6, the probability is 1 over 6 because the die is a fair dice, right? So to get another 6 for the second dice, also 1 over 6. The third one also 1 over 6. For the case of 665, also the same. I'm having 1 over 6, 1 over 6, 1 over 6, and I need to multiply it with 3. Alright, and you add them together and simplify them. By right, we should have 1 over 54 as the answer. Alright, and please take note that this is only the probability for the score, which is more than 17. And now they are saying that the score more than equals to 17 first obtained on the 6th row. That means if I want to write out or calculate the probability for this part on 6th row, okay, so that means for the first row, I didn't get a score, which is more than equals to 17. So the probability for the first row less than 17 should be 53 over 54 because more than or equals to 17 is 1 over 54, right? And then the first row I didn't get the score more than 17, so should be 53 over 54. Same thing happened for the second row, also 53 over 54. Third row also same. Fourth also same. The fifth row I also didn't get the score yet, which is more than equals to 17. So the sixth row only I get the score more than or equals to 17, which is 1 over 54. Right? So usually when we want to simplify this, when we want to write out a step for this one, right, we are using the geometric distribution formula where we should have Q is 53 over 54, the complement of the P, okay, power 5, and then I'm having the sixth row, I get the score, which is more than or equals to 17. Then simplify it, I will have 0.0169. Okay, so this one, the step here in front basically is by understanding, and then this is basically the simplified version for the solution here, and it is actually the geometric distribution formula, alright, for general case, okay, for geometric distribution. So this is what we have for part A in question number 3. Alright, so let's have a look for part number B. For part number B, they want us to find that a score of 17 or more is obtained in fewer than 8 throws. Okay, so before we calculate this probability, just need to recall back in a geometric distribution, we actually have the general formula, geometric distribution, right? Okay, so we actually have the formula where x is smaller or equals to r. Okay, there's a 1 minus q power r. This is a general formula that we can apply straight away, okay, when they're asking for this kind of probability lah. And now if you observe our question, they ask for the number of throw, okay, the score of 17 or more is obtained fewer than 8 throw. So the number of throw is fewer than 8, which means that I'm having x smaller than 8, no equal sign. And to apply this formula, I have to change it into the symbol with the equal sign. So I will say that x smaller than 8 should be x smaller equals to 7. Correct or not? So now I can apply this formula where it should be 1 minus q. Q is 53 over 54 power r, which is power 7. So from here, we'll get a long value, and I will cut it short into 3 significant figures where it should be 0.123. Okay, so please make sure that we can identify the geometric distribution in this question, and then we can solve it by using the geometric distribution formula in general. Right, so this is how we answer question number 4. We have the time taken in minutes to complete the work processing task by 250 employees in a particular company, and then they are summarized in the table. So we are having the time taken with frequency. First question, we need to draw a histogram to represent the information. Okay, so first of all, before we want to draw or sketch the histogram, we will need to check the class boundary first. So you can see that the first class limit is 20 and the second lower class limit also 20. So which means that all the values given here, there's no gap between them, and all these are class boundaries already. If we try to observe the width for the classes given here, so the width will be upper class boundary minus lower class boundary, right? So for this particular class here, 20 minus 0, I get 20. 40 minus 20, I get 20 also. 50 minus 40, I get 10. Then this one also 10, and this is 40. So you realize that all these are unequal width class, right? Or unequal width class boundary. When we're having unequal width class boundary in the question, basically when you want to draw the histogram, I actually need the frequency density. So how to get the frequency density? In general, the formula for frequency density will be equals to frequency divided by the width. Since we know the width already, okay, so we need to calculate all the frequency density for the classes here so that we can proceed with the histogram, right? So for the first class, I'm having frequency 32, then the width is 20, right? So to get the frequency density, I'm having 32 divided by width, which is 20, and I get the frequency density 1.6. So this is the frequency density for the first class, and please take note that we need to draw the 1.6 as the height of the first class when you want to draw the histogram. Okay, and then the second class, I'm having frequency 46, then the class width is 20, so I'm having 46 divided by 20, and I get 2.3. So this is a frequency density for the second class. Okay, so we'll continue for the rest of the classes as well. So I'm having 96 divided by 10, I got 9.6. The fourth class will be 52 divided by 10, I got 5.2. And the last class is 24 divided by 40, then I get 0.6. Okay, so please take note that all the calculation or all the value for the frequency density must be shown in somewhere of your solution in the exam paper. Okay, so please show them all the value clearly here. And after that, we can proceed to draw the histogram. Okay, so before you can draw the histogram, let's label the x and y axis. Okay, so I will make it smaller so that you can see clearer. I need a value for all the frequency densities. Alright, and if you try to sketch, maybe I'll start. I want to label my x-axis first. Okay, where this is time, and then with the t minutes. Alright, and our y-axis will be frequency density. Okay, so I'm having frequency density for my y-axis. Then I will want to label it. So the highest value is 9.6. So maybe I will put it like this in this ratio 2, 4, 6, 8, 10 for the y-axis. And then for the x-axis, what do I have here is maybe I can have 20, 40, 60, 80, and also 100. This is 0. Okay, so for the first class, the height for the first class is 1.6, which is the frequency density, right? So you'll try to measure where is the 1.6, and then I start to sketch the bar. And for this bar, the width of bar is from 0 until 20. Therefore, if I draw, I need to draw until 20. Then this is the first bar that I have. Okay, so this is the value 1.6, and this is the first bar. How about for the second bar? The second bar, the height is 2.3. 2.3 by right should be here, and also the width is 20 unit. So this is 2.3, and I try to draw it with the width 20. Okay, and after that, the next class, it will be 9.6 with the height 9.6, and also the width is 10 unit only. So 9.6 and 10 units should be somewhere here. Okay, so by right, you can see that the third bar now is slimmer actually, not so thick like the first two bar. Okay, so maybe for your case, you can use a ruler to draw it nicer, right? And then for the next one, the height will be 5.2. So 5.2, the width is also 10 units, so 5.2. And the last class here, the width is 40, which is very wide. Then the height is 0.6. So 0.6 is quite short. Okay, so if let's say we didn't do any careless mistake, by right your final answer should look something like this for the histogram part. Okay, and you can observe that the bar of the histogram is different, has different width, and for the y-axis we are drawing frequency density but not the frequency. Okay, so this is how we answer part A for question number 4 to draw the histogram. And we can proceed to part number B. For part number B, they are saying that from the data, mean is actually 43.2. So they actually want us to calculate an estimate for the standard deviation of these times. Okay, so let's recall what is the formula for standard deviation. So to get the standard deviation formula, the easier one should be summation of fx squared divided by the summation of f minus the mean squared. So by right, this is the question that we should have lah. And then for this question, because they are mentioned about t, so maybe for me I'll just put it as t. So ft, then multiply with minus the t, the mean of t squared, mean t, the mean of t, and then you need to square the mean. All right. Okay, so first of all, let's find out the summation of ft squared first. What's the meaning for summation of ft squared? Basically, it means that you take the frequency, multiply with the midpoint of the class, and you square the midpoint of the class. So as an example, if we refer back to the question here, our midpoint for the first class is 10. 0 plus 20 divided by 2, I get a 10. This one, the midpoint is 30, midpoint is 45, 55, and also 80. So you have to square the midpoint, then you multiply with the frequency. And our solution will look something like this. For the first one, frequency is 32, multiply with the midpoint. Midpoint is 10 and I need to square it. Frequency is 46 for the second class, midpoint is 30 and I need to square the midpoint, and so on. And then the last class will be frequency 24, then the midpoint is 80 and I need to square it. Okay, so for the summation of ft squared, I have the value 549900. Then to calculate the standard deviation, I will just plug in all the values into the formula, where I have 549900 divided by the summation of frequency, which is 250, minus the mean 43.2, and then you need to square it. Alright, so if you didn't do any careless mistake here, by right you should get this value. And of course we will correct it to 3 significant figure, therefore the answer for standard deviation will be 18.3. Right, so this is how we solve question number 5. Eric has 3 coins. One of the coin is fair. The other 2 coins are each biased so that the probability of alternating a head is only 1 over 4, independently of all other throws. Eric throws all the 3 coins at the same time. We have event A and B defined as follows. So for event A, all the 3 coins show the same result. And for the event B, at least one of the biased coins show a head. And now they want us to calculate the probability that the event B, the probability for event B is 7 over 16. Okay, so how are we going to show this? They are saying that at least one of the biased coins shows a head. So it can be one biased coin show heads or both biased coins show heads. So to calculate this in an easier way, maybe we can actually take the opposite way, where we take the total probability 1 minus the case where the both biased coins show tails. Instead of we try to find out the 2 cases where at least one of them show head, right? So how about we try to find out both biased coins show a tail, and I have to take the total probability 1 minus this event. Okay, so I'm having 1, then minus. Let's talk about the coin, which is a fair first, fair coin. For fair coin, right, I can take any value for the fair coin, so the probability should be 1. Then for the second coin, where it is the biased one, okay, to get the tail, I'll have the probability 3 over 4. Then for the next one, also the biased coin also show a tail, the probability will be 3 over 4. Alright, so when we try to simplify all the value here, I will take 1 divided by, 1 minus 9 over 16. And from here, very easily we'll get 7 over 16. Okay, so this is how we calculate the event B, right? Okay, so we are taking the opposite thinking. If let's say you want to use the cases, or you want to use another method to calculate, then you have to consider 2 cases, where first case is only one biased coin show a head, then the second case is both biased coins show a head, also can. Alright, so this is how we get 5A answer. Then let us continue to 5B. Okay, so for 5B, they want us to calculate the conditional probability where A happened given that B already happened. Okay, so again, to calculate the conditional probability, like what I mentioned earlier just now, we need to write out the general formula first, where A intersect B divided by the probability of B. What's the meaning for A intersect B? Okay, so let's have a look for the definition for the event again. A means all the 3 coins show the same result, and at least one of the biased coins show a head. Okay, so if you have an intersection for this one, right, the possible result will be head, head, head. That means this is the fair coin shows head. Okay, then the second, the bias coin show head. The second bias coin also show head, right? And this is the only case that fulfill the intersection for these two events, because all of the three coin must be the same result, and then at least one of the bias coin show a head. Alright, so to get the same result, this is the only possible case, H, H, and H. So we will put in the value here. So for A intersect B, I need to get the probability for H, H, and H. To get the head for the fair coin, I will have 1 over 2. To get the head for the bias coin, it will be 1 over 4. For the second coin, also bias coin, to get the head is also 1 over 4. Then divided by the probability of B. For the event B, we already get the probability just now, which is 7 over 16. So I put in 7 over 16 here, and I try to simplify everything. Okay, to simplify it, I will get 1 over 14, or correct to 3 significant figure, the answer should be 0.0714. So this is how we get the answer for this part. Then proceed to part number C. Okay, so for part number C, they are talking about the number of hits obtained when Eric throws the 3 coins. Draw up the probability distribution table for X. Okay, so to get the probability distribution for this random variable X, they are concerned about the number of hits when we throw the 3 coins. Okay, so there are many ways for you to solve it. Some will use the analytics, so maybe they try to think in their mind, okay, what are the possible cases that we have, and then they list out the events, all right, or list out the possible cases. So for me, I think the safest way, I will just draw the tree diagram and show you what happened basically. So this is the first coin. Okay, so the first coin is a fair coin, so I'm having half and half. Okay, then for the second coin, they are biased, right? So I'm having HT and also HT. Since they are biased, therefore, this is a second coin, and this second coin is a biased coin. So to get the probability, head part will be 1 over 4. The probability for tail will be 3 over 4. 1 over 4 and 3 over 4. And after that, I'm having the third coin also showing the head tail result. And they are still biased, right? Okay, so the probability for the head will be 1 over 4. The tail will be 3 over 4. Okay, so after I draw the tree diagram, basically I can simplify what is the final result here. So for the first pathway, if I show it for the first pathway, this is the first pathway, right? Then from here, if you try to observe, basically I'm having 3 heads. So they are concerned about the number of heads, which means that for this case, I'm having x equals to 3, number of heads equals to 3 for this outcome or this pathway. Okay, so how about for the next pathway? Next pathway, I'm having something like this. So for this one, you can see very clearly that the value for x, or the number of head, is actually 2. So you should write it out as x equals to 2. Okay, then I do the same thing for the rest of the branches. Right. Okay, so I will have 8 outcomes in total. Okay, where this one should be x equals to 2 also. Then this one should be x equals to 1, x equals to 2, x equals to 1, x equals to 1, x equals to 0. So for the 8 outcomes that I have here, you can see that I list out successfully all the value for the x. Okay, so we're having x equals to 0 and the x equals to 3. And to calculate the probability, I will need to total up, multiply all the probability for the pathway and total up if let's say they have different cases. So as an example, for x equals to 0, I have only one pathway. So I just multiply the probability together. So I'm having half, multiply with 3 over 4, multiply with 3 over 4. So if I simplify this probability, I'm having 9 over 32. Okay, then calculate the probability for x equals to 1, if you try to observe, right, for x equals to 1, we are having a few pathways. So I'm having this as the first one. Then I'm having this as the second one. Then this one as the third one. Alright, so to calculate the probability, I just multiply the probability along the pathway. Then you add it for the other case, other branch, right? And then I'm having half, then 3 over 4 multiplied with 3 over 4. So for your information, the solution here, I'm writing from the bottom to top. Okay, so if you want to check, so half, 3 over 4, 1 over 4. Okay, then half, 1 over 4, 3 over 4. Then half, 3 over 4, 3 over 4. Okay, then if I simplify the answer for x equals to 1, then I will have 15 over 32. Okay, then next one, x equals to 2, so you do the same thing. We'll do the same thing for x equals to 2 lah. So we try to figure out what are the possible pathway that we have for x equals to 2. Okay, so I'm not going to highlight anymore. You can observe it from the tree diagram here. So for x equals to 2, I'm having all this outcome. And then I'm having the same outcome here. So I just multiply it with 2 lah. Okay, then simplify the answer for this part. By right, you should get 7 over 32. And the last result is x equals to 3. So we have only one case for x equals to 3, where it should be half, 1 over 4, 1 over 4, and then I'm having 1 over 32. Okay, so after I get all the probability already, I try to double check the total of the probability. Is it equals to 1 or not? Okay, so if I try to add all the probability that I get here, I get the total equals to 1. Therefore, I can simplify into a probability distribution table. Where this is x equals to x, and then I'm having the probability. Okay, so x can be equals to 0, can be equals to 1, equals to 2, and also equals to 3. And the probability shown here will be 9 over 32, 15 over 32, 7 over 32, and also 1 over 32. Okay, so you can see that this is our answer. Okay, so for this question, right, there are more than one way that we can get the answer. But for me, I feel that if I try to sketch the tree diagram, it can clearly show me all the possible outcome and also the value for x that we can have in this incident. Alright, and also by drawing the tree diagram, I can write out clearly all the possible probability for every single cases here. Since we are having the fair coin and also the bias coin, right? So if we can list out everything, at least we are not confused when we try to calculate any probability later. Right? So this is the suggested way that I will suggest you all to use, okay, to answer this question here. Alright, okay, so this is how we answer question number 5. Okay, so now we come to question number 6. At the company's call center, there are 90% of the callers are connected immediately to a representative. So a random sample of 12 callers is chosen. So find the probability that fewer than 10 callers are connected immediately. Okay, so for this question, we are having a larger number, which is 12 callers, and then fewer than 10 callers, something happened to them. So when we are having the structure of this kind of question, basically it is binomial distributed. So x is the number of callers that respond or connected immediately, and it is binomial distributed. The total number for n, or the total number of callers, will be 12, and then the probability of connected immediately to the representative will be 90%. And if you write out into the probability form, it will be 0.9. Okay, so this is my p in binomial distribution, and 12 is the n. They are interested to find out the probability that x, the number of callers, which is the x, fewer than 10, so less than 10, are connected immediately. So for So x smaller than 10, right? By right, we should include the probability that x equals to 0, x equals to 1, until x equals to 9. So to me, I think it is too long. I will want to take 1 minus x equals to 10, x equals to 11, and also x equals to 12. For x equals to 10, I'm having 12c10, 0.9 power 10, 0.1 power 2. So you should try to link back with the binomial distribution formula. Okay, so this is the probability for 10 equals x equals to 10, and I also want to minus x equals to 11. So 12c11, 0.9, 11, 0.1 power 1. And of course, included also need to minus 12c, x equals to 12 lah. So 12c12, 0.9 power 12, 0.1 power 0. Then by using the help of calculator, simplify the answer, you should get the answer correct to 3 significant figure, which is 0.111. Okay, and now we proceed to part B. Okay, so for part B, we are having a larger group. So we are now having 80 callers. 80 callers is chosen. Use an approximation, highlight the keyword approximation to find the probability more than 69 of these callers are connected immediately. So for this question, the keyword is very, very obvious where they ask us to find out or use the approximation. For AS syllabus, we are having only one approximation where originally our x is binomial distributed, and then we are going to change it become normal distribution. Okay, so to change binomial become normal, I need the mean. So the mean here should be n times p. 80 multiplied with 0.9. Okay, so I'll get 72. Then for the variance, it should be npq. 80 multiplied 0.9 multiplied with 0.1. So I'm having 7.2. So for those who need the formula, just to write it out, it just in case you need it, right? So np and npq. np is the mean. npq is the variance for binomial distribution. Alright? And now they want us to find the probability that x is more than 69. So greater than 69, there's no equal sign here. From binomial to normal, binomial is discrete random variable, and then the normal is continuous random variable. Alright, and therefore if we want to calculate the probability, we should actually apply continuity correction first. So for this case, more than 69 means that includes 70. The continuity correction should be 69.5. Okay, then after the continuity correction, before we can calculate the probability, we have to standardize the x becomes z, where I'm having 69.5 minus the mean that we calculated just now, 72, divided by standard deviation. So 7.2 is a variance. I need to take square root 7.2 to get a standard deviation. Okay, so this is the process of standardization. Get the value for z into 3 decimal places, which is negative 0.932. This area is the same as z smaller than 0.932. Okay, and then get the probability from the normal distribution table. 0.932, right? So you should look for 0.9, and then 3 should be this one, and then 2 should be this, which means that you take 8, 2, 3, 8 plus 5 at the last digit. Okay, and we will get the answer 8243. Of course, to be on the safe side, we will simplify the answer into 3 significant figure, where it should be 0.824. Okay, so this is how we answer part B. And if you have a look for part C, they want us to justify the use of approximation in part B. Okay, so for your information, right, we cannot simply change the binomial become normal distribution. There are some criteria that we need to ensure that the question here fulfill the condition. Okay, so what are the conditions? Basically, there are a few here. The first one is the n must be larger. which is greater equals to 30. For our question here, our n is very large, which is equals to 80 already, and it fulfilled, right? Okay, then the second criteria is NP must be greater than 5. If you try to calculate the NP for this question, you get 72, which is also fulfill the criteria for NP greater than 5. And the third one will be NQ greater than 5. If we try to use n times q here, we'll get the value 8, which is also greater than 5. So these are the reason, or maybe these are the criteria that we need to check before we can change binomial become normal distribution. Alright, so now we are at the very last question for this paper. They want us to find the number of different arrangements. So I think highlight the word arrangement here. Okay, so it actually means that later it gives us a hint that later when we want to calculate the number of ways, right? We usually will use the permutation, right? Either NPR or maybe n factorial. So we're having 9 letters here in the word alligator, in which the two A's are together and also the two L's are together. Okay, so to calculate this probability, first of all, we try to find out what are the letters that we have here. So we can see quite clearly that we have the, how to say, we actually have the identical letter, right? Okay, so usually I would prefer to list out. So for this alligator word, I'm having 2 letter A, 2 letter L, 1 letter I, 1 letter G, 1 letter T, 1 O, and also 1 R. Okay, so usually I will try to list out all the possible letters first, and then here they want us to find the number of different arrangement for the 9 letters in this word, which the 2A are together and the 2L are together. So now the restriction for this case is I'm having 2A together and also 2L's together. When we have 2A and 2L's together, right, what we do is basically we bundle the both A together as one unit. So I will treat it as one unit only. And then for the 2L also, I bundle them together and I will treat it as one unit as well. So that means no matter how we arrange, right, since we treat it as one unit, now they will not be separated. So it fulfills the condition that we have here, the A and L are together. Okay, then I have I, G, T, O, R. If you try to count, right, how many letters that do we have here? 1, 2, 3, 4, 5, 6, 7. So we are going to arrange the 7 letters here. Therefore, the number of permutation will be 7 factorial, and it is equals to 5040. Okay, so for this question, you no need to consider the arrangement inside the group of A and also the group of L because they are identical letter. Alright, so we just need to calculate the number of arrangement in overall only. Right, so where we are having 7 items, and therefore the formula should be 7 factorial. So this is how we answer question number 7A. Then let us proceed to 7B. Now the letters are in the word are arranged in a random order. So again, arrange. So find the probability that the two L's are together. There are exactly 6 letters between 2A. Okay, so there are some restrictions here also, right? And we are interested to find out the probability. Okay, so to find the probability, first of all, I want to get the probability without restrictions. I want to get the number of ways without restrictions. Okay, so for the number of ways to arrange the 9 letters here without restrictions, right? I'm having 2A, 2L, 1I, 1G, 1T, 1O, 1R. Okay, so I just list out again. So from here, I'm having 9 letters. Okay, then from the 9 letters here, there are 2 identical A. Therefore, I have to divide it by 2. 2 identical L also, I have to divide it by 2. And the total arrangement without the restriction should be 90720. Okay, and after that, you want to calculate the number of ways that fulfill the restriction here. So they said the two L's are together. this one of the restriction, and then there are exactly 6 letters between the two A. If I want to have 6 letters between the two A, right, I will need to try and write out. So this is the maybe the A, then must be 6 letters between 1, 2, 3, 4, 5, 6, and then the next A will appear here. And then if I calculate the total number here, 1, 2, 3, 4, 5, 6, 7, 8, right? By right, there's one more letter at the end. Okay, all right. So this is what I have. And then we might also have the case where the 6 letters between the A is like this. A, first letter, any other letter, then A, then 1, 2, 3, 4, 5, 6, and then A. So these are the two possible cases where the A has exactly 6 letters between them. Okay, all right. And then now the second restriction here is they want us to have 2L together. So 2L together means that the L must be either like this, which is 1, then the L can be here, which is 2, the L can be here 3, then this one 4, and then this one 5. That means for the both L here, basically they are having 5 different positions to be placed, okay, between the spaces in the A. Okay, and then same thing happen for the second case here, all right, also 5. Okay, so for A, I have 2 ways to put the A with the 6 letters in between, and then for the L, I'm having 5 ways to put the L, so times 5. And after that, if you already locate or if you already place the both L, right, let's say I'm having both L here, they are together, and then I have to arrange the remaining letter. So I'm having 1, 2, 3, 4, 5. To arrange 5 letters and all of them are different, by right it is 5 factorial. So 2 times 5 times 5 factorial, then we are having 1200. Okay, so you can put a small note if you want to understand it better. The 2 here means the 2 cases where you are having 6 letters between A. And then for the 5 here is the L. The position for L must be together. Okay, then of course for this one is to arrange the remaining 5 letters. Arrange remaining 5 different letters. Okay, then after I get the number away with the restriction, after I calculate the number away without restriction, so we can combine them, become the probability. So what's the probability here? It will be 1200 divided by 90720. Then fraction is 5 over 378. Or if you want to change it become 3 significant figure, it will be 0.0132. And this is how we calculate the probability. Alright, and let us proceed to the last part, part C. Okay, so for part C, they want us to find the number of different selections. So highlight the keyword selection. It is about the combination later. So selection of 5 letters from the word alligator, then will contain at least one A, then at most one L. Okay, so again, I will try to list out. Okay, so I'm having 2A, 2L, 1I, 1G, 1T, 1O, 1R. I need to try and list out for the number of selection for combination, right? Especially the cases where we have the identical letters, we actually need to list out the cases, the case by case. Okay, so we have to try to list out what are the cases, possible cases that fulfill the requirement here or the restriction here. They want to have at least one A, at most one L, and I want to select 5 letters. Okay, so at least one A and at most one L. the first case is I might have 1A with 0L. You have at least 1A lor, and most 1L so 0L means fulfill the restriction, right? If I have 1A 0L, then I have A, and then 4 more letters to be selected. Okay. Second case, I might have 1A with 1L. Okay, so if I have 1A, 1L, that means I have 1A, 1L here, and then 3 more letters to be selected besides the A and L. Okay, so third case, what is the possible third case that I have? I might have 2A with 0L. They say at least 1A, so besides 1, I can have 2A also, right? If I have 2A and 0L, then my selection will be something like this, AA, then 3 more letters to be selected besides the A and also L. Then fourth case, I can also have 2A with 1L. If I have 2A, then I have an AA here, and then I have the L as the third letter. So for this case, we still have to choose another 2 letters besides the A and L. Okay, so for all the cases that I list out here, fulfill the restriction in the question. And now I will want to select all the letters now. When we want to select the letters, right, we should exclude the A and L, because if we include the A and L in the selection, it will actually mix up our cases. Right, so since we already list out all the possible cases for A and L, right, so we should actually ignore the A and L in the selection. Okay, so for the 4 letters here, I am going to select it from the 5 letters here. So it should be 5C4. So 5C4 means that from the 5 letter, I want to choose 4. Selection means combination. So I have 5C4, which is equals to 5. Okay, then for the 3 letters here, it should be 5 letters. I want to choose 3 of them. Okay, the 5 letter here, I want to choose only 3 of them. So it should be 5C3, which is a 10. Same thing happened for this one. I still have 3 empty space. So also 5C3. Then the last case here, I have only 2 empty space. Therefore, it should be 5C2. So after we find out the possible selection for every single cases, we try to total them up. The answer should be equals to 35. Okay, so this is how we answer the questions in this paper, October, November 2022, paper 5-2. Alright, so thank you very much for watching this video and also your support.